and welcome to another BCNL webinar. My name is Rudolf and I'm the founder of BCNL. First of all, welcome everybody who is attending, and especially the guys from Zilliqa. So let's dive into it straight away, and I would like to give the word to the guys from Zilliqa.
Hello, hi everyone. Hi, my name is Amrit. And I have with me my colleague Arnav Vohra, who is the developer evangelist, and I am president and chief scientific officer at Zilliqa. So what we have in today as planned is we will have a 10 minutes presentation to give a very high level overview of Zilliqa and the core features of Zilliqa. And after that, we will have a separate presentation on Scilla, which is a smart contract language that we have developed for Zilliqa to develop smart contracts and DAPPS on top of the platform. So I hope you can hear me clear. I'm going to share my screen just in a second, and then we can start the presentation. Okay, so thank you very much for joining this session. As I said, my name is Amrit Kumar. I'm the president and chief scientific officer at Zilliqa. And this first 10 to 15 minute session would be mostly about giving an overview of what Zilliqa is, what we're trying to do, and what the Zilliqa ecosystem is about. And then after that, we'll have a separate session on Scilla, which is the smart contract language for Zilliqa. So Zilliqa started back in, I would say, June 2017. And prior to that, actually, most of the founders who were involved at Zilliqa were actually researchers based at National University of Singapore. And this is where most of these researchers were looking at blockchains from a scalability perspective. So around that time, we were looking at, the ICOs were happening like crazy. And then a lot of volume was being sent, a lot of transaction volume was being sent to Ethereum chain. And we all noticed that the transactions actually choked the Ethereum chain for quite a while. And so it was around that time that we were looking at, these researchers and founders were looking at how to solve that scalability problem for blockchains. And then they did a research and published an academic paper in one of the top conferences in security. And that paper eventually became Zilliqa. So it was around, I would say, last January that we released the mainnet. And that mainnet didn't allow people to run smart contracts. It was only allowed last June, I would say. So roughly speaking, Zilliqa is around a year old. And now we have quite a few applications running on the Zilliqa chain, which clearly shows how scalable and how performant the chain can be in practice if you implement this idea called sharding that Zilliqa uses. So there are two basic principles or two basic features that we tried to, two basic problems that we wanted to solve. First was to solve the scalability problem. So to make sure that the blockchain can scale as more transactions come to the network. And the number two was to improve some of the issues that we're seeing with smart contracts. So we had seen incidents like DAO happen, where a contract was hacked and a substantial amount of money was stolen from that contract on Ethereum. And that because of that, two Ethereum chains actually started to pop up. One was Ethereum and the Ethereum Classic. And then a bunch of other recent set of incidents happened with smart contracts, and we felt that it has to stop and we have to do something about it. And this was the basic idea behind Scilla, which is the smart contract language that we developed for Zilliqa. So these are, I would say, the two basic features that two problems that Zilliqa tries to solve. So at a very high level, right now, if you see the blockchain space and the traditional finance space in some sense, there are two extremes. On one extreme, you have the traditional financial setup, like banks, mortgage providers, you have insurance, and lending borrowing platforms, for example. And then on the other hand, you have fully decentralized DeFi solutions, for example, MakerDAO, which allows you to issue a stable coin that's backed by a volatile asset, a crypto asset like Ethereum, for example. And so what we felt was there was a huge gap between these two sectors, and they all had different user base. So traditional finance had its own user base and customer base. And this DeFi has actually, or this blockchain space in general, has actually created a new consumer base that is very tech savvy, and they like technology and they want to be a part of that financial freedom in some sense. And what we felt that it would be good to be able to bridge that gap in some way, so that you could have users in the traditional finance and you can bring them somehow towards towards the blockchain finance in some sense. And why would we want to do this? Because if you look at some of the sectors that we are actually focusing on, especially in the region of Southeast Asia, which includes, for example, countries like Singapore, Malaysia, Indonesia, and even including India, there is a considerable number of people who are underbanked and unbanked. And if you look at, for example, any blockchain asset, getting a blockchain address is pretty straightforward. You can literally click a button and you can get your address, which is almost equivalent to getting a bank account. So it's very easy for you for this blockchain system to onboard new unbanked and underbanked customers and give them access to traditional to this new financial assets. So we felt that our vision would be to connect these two extremes. So the traditional financial world and this upcoming, and very dynamic blockchain backed finance, and be able to bridge that somehow. And with a focus in APAC and ASEAN, so be able to focus in this geographical region, because we feel that region really needs a little bit of liftoff in terms of financial inclusion. So our approach has been sort of three ways. So first is to be able to build a platform that will be able to support the use case and be able to support the transaction volume that can come if you're on board some of those financial applications. And that's why we decided to build Zilliqa, the platform, and Scilla, which will be able to provide you a safe smart contract platform and automation platform to support and to hold very high value assets without sacrificing security, for example. So once we have this base layer, we wanted to build, of course, some sort of anchor application, anchor products that we can use and to reach out to the customers in this region. So right now we have two basic products that I would say is the base layer for those applications and those products. And one is what's called the Singapore-backed dollar stablecoin. So it's a fiat-backed stablecoin, which is being developed on top of the Zilliqa chain. It's developed in partnership with a company called XFIS. And the second part is that we are working on is the Edgy exchange. So it's an exchange that will allow people to trade private equities. So if you have a private company that for which you want to issue your equities, and you want that equities to be tradable in a marketplace, then EdgyX could be that solution for you. And obviously, there's nothing complete without a vibrant ecosystem. So we also have set up a dedicated mechanism that we call Zilhive. It's an incubation program to encourage people or teams around the world who like to build on top of the Zilliqa chain. And the Zilhive provides them financial, technical, and marketing support so that their products can actually get the right consumers and reach to the right consumers. So as I said, the base layer is Zilliqa, and we tried to build Zilliqa in a way that Zilliqa and some of these underlying, or let's say the accompanying toolkits, in a way that they are modular, so you can easily try to combine some of the tools in some way. For example, a lot of people right now are building wallets on top of that will, for Zilliqa chain, and those two wallets now are actually trying to combine with some of the toolkits, for example, an IDE, which allows you to develop contracts on top of Zilliqa. We are also building or collaborating with projects or companies that can provide some modular architecture. For example, an entity that can provide, for example, compliance to see whether any illicit activity is happening on the Zilliqa chain or not. Because if you're trying to build this bridge between the traditional financial world and the blockchain world, you need to be able to make sure that you can have the appropriate license, and those licenses will require you to have compliance checks. So we are also building some of those, or actually partnering with some of those providers who can provide the right basic tools that can connect and that you can use as a developer to build your tools and apps and use some of those compliance tools. So at a very high level, Zilliqa blockchain solves this scalability problem through what I call the idea of sharding. And in very basic terms, sharding is basically divide and conquer. So you start with a large network of nodes and you divide them to smaller groups of smaller nodes, a smaller set of nodes, such that each smaller group can process transaction parallel compared to the other group. And what ends up happening with this result is that the more smaller groups you have, the more transaction you can process. And this is kind of, we saw with an experiment that we did on our private testnet, is that once your network has, let's say, 1,800 nodes, it can process around 1,200 transactions per second. And when you double the size of the network from 1,800 to 3,600, you double your throughput from 1,200 to 2,400 transactions as well. And it gives you what we call linear scalability. So the more nodes you have, the more throughput you can get. And that's how the whole platform becomes scalable in terms of transaction volume. And as I said earlier, we also decided to build a new language that we call Scilla. So Scilla has been designed with safety in mind. And the whole reason why we decided to develop this language was because we felt that Solidity, which is the main language, smart contract language that people use to build on top of Ethereum, we felt was not designed with safety in mind. And that's why we saw series of attacks and hacks that happen on Ethereum chain, especially smart contracts, and millions of dollars worth of assets were stolen, hundreds of millions actually of assets were stolen from those contracts. So we felt that it would be good if we can design a language that's safe by design in principle, so you could eliminate some of the attacks that we have seen in the past. At the same time, it would be good if we could formally guarantee that this contract exactly does this and nothing else. So for example, if this contract holds certain number of assets, then you can guarantee that this contract will not leak funds to other contracts, or will not allow anyone to steal funds from this contract. So you can actually prove that, give a guarantee, a mathematical guarantee that this holds for this contract. And Scilla, due to its design, allows and makes it much simpler to do this. So here's a very quick overview of what the current ecosystem looks like. So we have on the top left a big chunk of fiat to crypto on-ramp providers. We are building some decentralized exchanges as well. So Switcher Network is a decentralized exchange, something very similar to Uniswap if you're familiar with this exchange on Ethereum. And for example, a Mintable, which is a decentralized marketplace for NFTs, so non-fungible tokens. I talked about Security Exchange and GX earlier, and Xverse as a stable coin. Elliptic is one of the partners that has integrated their chain analysis tools with Zilliqa. So if there's any illicit activity that happens, then Elliptic would be able to flag that to a DApp developer, for example. A very quick outline of what we're looking at into 2020 as a roadmap. So as I said earlier, we released our mainnet back in June 2019. So we are roughly speaking a year old. And this is the time when we are slowly moving towards what I call Zilliqa 2.0, which will try to improve the throughput of the network. So we want to push the throughput limit to even further. We want to reduce the latency of the network. So we want to make sure that the time it takes for transaction to be processed goes down. At the same time, we're also looking at, as you can imagine, since Scilla is a new smart contract language, we have to develop tools that will support development on top of the Zilliqa chain. So we're also boosting the toolkits that developers would need to be able to develop on Zilliqa chain. A very quick summary of what we have built as a product. So as I mentioned earlier, we have a Singapore dollar-backed stablecoin called XSGD, developed through a partnership with a company called Xverse in Singapore, and a security token exchange and issuance platform in partnership with some of the local partners in Southeast Asia called XG Exchange. So Xverse is actually the one issuing XSGD, and it's a regulated entity in Singapore. So they have the license to operate, or what very simply can be put as an e-wallet, and they're using that to be able to issue this stablecoin contract tokens on top of Zilliqa. And they're also trying to extend this to Indonesian rupiah-backed stablecoin. So you could have Singapore dollar stablecoin on one end, and then Indonesian rupiah-backed stablecoin on the other end in Indonesia. And then you can imagine, for example, use cases, for example, remittance that you can build through these two endpoints as stablecoins. XG Exchange, for example, is, as I mentioned earlier, the idea is to build a marketplace and be able to provide a platform where private company owners can issue their tokens. And it's currently in the process of getting a license from AES. So we should be able to have an operating model by in June this month, and then that will be in a sandbox situation. So we would be able to test with some assets and check if everything works well or not. So this is going to be very live very soon, and has a potential to to capture private equity's space in this region in particular. Last but not the least, we have, I mentioned earlier, we have the Zilliqa program, which is an incubation program for people who have ideas to build and develop on top of Zilliqa. It's a program that provides, as I said, financial support, but more than that, it also provides marketing, tech support, and mentorship if that's needed for teams and projects. That's it on my end. Thank you very much for your patience and for indulging me.
Yeah, hi everyone. And I learned the way to say Dutch in hi everyone in Dutch, which is, I think, hallo iedereen. So hello iedereen. As Amrit had mentioned, we have our own smart contract programming language known as Scilla, and in this session, I'll talk about that. We'll discuss about what are the USPs of Scilla, why we decided to create our own smart contract language, how does Scilla differentiate from Solidity, and so on and so forth. So this is the Zilliqa overview. Amrit, I think, had already mentioned this, so I'll not go in depth for this. But yeah, just to give you an overview of how Zilliqa compares with other chains. So here I have a graph comparing Zilliqa with 4 chains, that is with 4 chains, that is Bitcoin, Ethereum, Tezos, and Cardano. And Bitcoin, of course, doesn't have support to write, it doesn't have a smart contract language built in. And if you look at the transaction throughput numbers, Zilliqa is the highest among all the chains, and we maintain decentralization as well to achieve those numbers. And we have the consensus algorithm that we use is proof of work plus PBFT, which is practical Byzantine fault tolerance. And if you look at the other chains, you can see, okay, that Bitcoin has proof of work, Ethereum has proof of work, soon shifting to POS, and so on and so forth. And the transaction finality of Zilliqa is instant. So the how PBFT works is, in PBFT, the nodes, we have various shards, and each shard has a number of nodes, and those nodes are actually signing a block, and then they are sending to a DS committee that actually combines those blocks that various shards send to create a we have these micro blocks, and we have a DS block. So what we have there is, we have instant finality. So if your transaction gets confirmed, there's no way that we might have like chain rollups as we have in, say, Bitcoin or other chains. Like in Bitcoin, we usually, it's recommended to wait for 3 confirmations before you say give a fiat to someone. Like if, say, you are a merchant and you are accepting money, usually it's recommended to wait for 3 confirmations, which is usually 30 minutes. And that's because there's a chance that the Bitcoin chain might get rolled back, in a way that people, the longest chain is the true chain, right? So there might be a chance that if we are at block 10, then block 11 gets mined, but we then get another chain in which block 11 and 12 also get mined, but the 11th block is not the same as the previous the other 11th block. So there might be a chance that the first chain, the 11th block there, might get actually rejected. So yeah, that's but in Zilliqa, that's not the case. The PBFT guarantees that there's instant transaction finality. So the user experience of a DApp also increases, because, like, if, say, you're a DApp developer, even if the transaction, say, gets confirmed on Etherscan, you have to wait for some more blocks till you are sure that the transaction is done. But in Zilliqa, that's instant. And just to give an overview on Scilla, so Scilla is, as Amrit had mentioned, It's a first peer-reviewed and safe by design smart contract language, and uses functional programming principles as are seen in OCaml and other functional programming languages, and it's friendly towards writing static checks and formal proofs. And it's non-Turing complete, so that actually helps. That makes it easier to write formal proofs. Although, yeah, there are certain restrictions to it being non-Turing complete. But what we figured out was, that almost all applications, all the prominent dApps that we envision or that are actually getting built in the community right now, in the blockchain community, they can be built with Scilla and it being non-Turing complete. So the question is, why a new programming language? What's the problems with Solidity? And as Amrit had mentioned, we had a $50 million DAO hack that led to the Ethereum hard fork, and we had like two chains, ETH and ETC, that is Ethereum and Ethereum Classic. You can argue which one is the true one. Ethereum Classic is the true one, or Ethereum chain. But eventually, they had to roll the blockchain back for the ETH chain, so that the DAO fork never happened in that chain. To an extent, it was a fault of how they had designed Solidity. And blockchain space was still new back then. So yeah. And we also had this $150 million parity multi-sig contract hack. So for the parity, this hack in which there was basically a noob who was playing with their parities multi-sig contract, and he accidentally killed the contract, and he opened a GitHub issue. And this screenshot is actually quite old. Currently, his GitHub account is deactivated, so you can't actually see it. But that's what happened. He opened an issue and he was like, okay, accidentally killed the contract. So what are the underlying causes with Solidity, right? So Solidity is complex, and there is no formal verification, and there is expected versus unexpected behavior. So these are the main underlying causes with Solidity. That's what we had identified.
Yeah, so we were talking about the Solidity contract, right, for the DAO hack. And essentially they had this, they had three steps. First, they figured out what amount. So DAO was basically decentralized autonomous organization, as I remember correctly, in which the people would deposit funds in a contract, and they would use those funds collectively to say, pool, make investments and do some interesting stuff. And people can, there was an option that people can actually reclaim back their funds. So the function we are looking at right now is the reclaim function. And this function did three steps. One was basically, it got the amount of from the amount that, so firstly it checked, okay, it checked how much amount is to be given to the person who is calling the reclaim function. And if you look at this contributors, this line of code, it just checks with the index of the message.sender, and then it calls message.sender.call.value, and yeah, it basically checks if this is false, then just throw an error, or otherwise make the contributors, the amount that belongs to the user, the sender, in the contributors part of the array to be equal to 0, because the person would have actually withdrawn the funds, right? So what essentially we have is, so if the sender was a normal address, then there was this code would have worked fine, right? There was not an issue. This would have run fine. Whereas if the sender, if the person, if the address calling this function within the DAO contract was a contract, which, contracts can call other contracts, then there was an issue. So what would happen was this statement would pass the control to this contract, and what could happen is that this contract would have some, say, malicious code running, and it never actually returns the control back to the DAO contract, and that code can actually keep on withdrawing funds. So if say yeah, it can keep on withdrawing funds again and again and again. So if the initial request for, say, was for 50 ether, then this contract would be able to call it again and again for 50 ether, 50 ether, 50 ether. And this part of the code is never the last line, in which the value of the address, the amount of the address, never actually gets set to 0. Yeah, and so what was the correct way to do this in Solidity would be to first actually do all the state manipulations, all the state contract manipulations, and then eventually transfer the amount to the address, and do any other or in general, that's the best practice, is to do first state manipulations and then call a contract or interact with the outside world. So the same contract written in the correct way in Solidity is we have the amount as set as we first get the amount that the user has to be sent back, and then we set the value of the user's amount back to 0, and then we transfer the relevant amount to him. And this is called check effects interactions. It's a design pattern basically. And how we solve this is at the Scilla level. We have solved this at the language itself, at the language level itself. So in Scilla we have transitions instead of functions. We call it, it's similar function, similar utility. We call it transition. And in transition, what happens is all the external calls always happen at the end, and they happen using the send keyword. And you can't actually do state. There's no way that you can do external calls and then you can do a state manipulation inside a transition. All the state manipulations happen first, and then the external call happens. And I can even show you an example of a Scilla contract. So this is like an example of Scilla contract, which is the fungible token contract, which is like ZR. We call it ZRC2. It's similar to the ERC20 standard on Ethereum. And if you look at any transition in this contract, you will see that we are doing all the state manipulations, or in general any other computation early, before doing any interaction with the outside world. So this is where the interaction with the outside world happens. And again, we use messages to interact with outside world. But yeah, essentially you can see all these transitions, and you'll find that and any interaction with the outside world happens at the end. Yeah. So we took this in mind. So all these things have been, there are so many other small details that have been kept in mind while designing Scilla, so that it's very difficult for someone to make these errors in contracts that are handling hundreds of millions of dollars. And similarly, just to give an overview of the parity, the multi-sig contract hack that happened was that we had this this function called init owner, and anyone was able to call this function, and they were able to set themselves as the owner of the contract. And yeah, this was again, Solidity does not have a clean separation between libraries and a non-library contract. And I think they have added the support for immutable variables with the recent update. But instead of the support for immutable variables, and those are basically variables that you can never change. That has been from day one. People can define certain variables. Like I can show you a contract here. So coming back to the fungible token example, if you look at this fungible token contract, we have these variables are known as immutable variables. These variables are the ones which actually never change. So after the contract is deployed, so you want certain things, certain, the, like, say, the owner aspect, the contract owner should should never change, right? So, people work in teams. Most developers work in teams, and say we have 3-4 people working on a contract. It might be the case that some developer accidentally somehow made this error that the parity multi-sig contract made. But if you're using immutable variables, you can't make this error in your contract. And in general, we also have the option to write libraries within the contract. So for doing mathematical computations or computations that don't change the state of the contract, we have this library. This is all library code, and this is written inside the contract code. So the contract definition, as we call it, starts here. And this is all code that can be reused within the contract, and this doesn't change the state. So it makes it easier to debug, easier to see what your code is doing. Yeah. Yeah, so as in this example, so $150 million were actually locked. So I think accidentally the user was able to make himself the owner, and he actually, when he was made the owner, he got the permission to kill the contract, and he killed the contract, and $150 million worth of ether were now locked. And that was a very prominent multi-sig contract that many other companies were actually using. Parity is founded by the original CTO of Ethereum. So people, and they have been hacked multiple times. So yeah, this is what the parity multisig hack was. And just to look at some Scilla design principles. So this, as I mentioned, there's some separation between computation and communication. Every in contract, computation is an atomic transition. The separation between effectful and pure computations, and every transition has to terminate the this is again inspirational from the functional programming design of Scilla. And as I mentioned earlier, the separation between invocation and chain contract calls. So every call to an external function is the last instruction of the transition. So yeah, these are some design principles that we have kept in mind. And why are Scilla contracts safe to write? Yeah, you can just have a look. It's all peer reviewed. Amrit was actually one of Amrit and Ilya. These two people were the one who were the main designers of Scilla, and it's peer reviewed. The Ilya is actually a professor at NUS. So yeah, you can read the Scilla white paper as well. And it's easier to write mathematical proofs for Scilla because of its function programming origins. And yeah, I talked about the Scilla design principles. There are security features of Scilla. So there's separation between mutable and immutable variables, libraries, and stateful contracts. This prevents priority-like incidents, and it handles arithmetic underflows and overflows. No need for using an external third-party library or an external library, math library. And we don't actually have for loops or while loops within Scilla to achieve a similar effect. There's structured recursion that you can do recursive code, and each transition actually terminates. And just to give a brief about formal verification, yeah, you can read the slides. Basically, it's a way to prove the correctness, and it's basically way to prove that what you're saying that your code is doing, it actually does that. Yeah, basically we use some maths. It's mathematical proofs that you write, and Scilla has been designed in such a way that auditors or people who write these proofs, they can use Coq Proof Assistant, and they can write proofs, mathematical proofs for their smart contracts. Yeah, and it's useful because people contracts, as I mentioned earlier, they hold lots of value. If say you have a contract that's holding $1 billion worth of assets, it's really beneficial to have a way to formally write a formal proof of what the contract does. And as a developer, you can sleep at night, I feel. Have a better sleep compared to writing a solidity contract. And yeah, so because if you are building the next $1 billion DApp or the next $1 billion application, as you grow, as the amount of money that's holding in your smart contracts increases, it's really it will really help you. Scilla will give you a very good night's sleep compared to solidity. And yeah, just to give you an overview of the dev tools, so we have our own IDE. This is our online IDE, and you can check your contract here. We use Scilla checker is what we call it. It checks your contract. So if say I make an error here, it will show me that I've made an error, and it's quite similar to Remix. And there are environments you can deploy your contract in a simulated environment, deployed on testnet, minnet. Right now I'm on testnet, but I can shift to a simulated environment and actually deploy this contract. Yeah, so that's the IDE part of it. If you go to ide.zilliqa.com, you can find this, and you can see that we have some sample contracts already written that you can play around with, and then you just select an account and you can just deploy the contract. And again, these are the initialization parameters. Yeah, you can I think playing around with the hello world contract might be good initially, and then you can move on to some advanced contracts. Also, if you are building a DApp, you definitely need to have front end website that is website or mobile app that's actually interacting with the contracts, the smart contracts. You don't have a backend, so as to speak. The blockchain is the backend, and the database both. And you have to interact with you have to query the blockchain to get data. And for this, we have Zilliqa JS library that has various modules that you can use to interact with the blockchain. We also have Go Zilliqa library and a Java version of it, but the JavaScript one is what most people use because websites are all JavaScript based. So it's quite a similar experience to working with any other blockchain platform. We also have some APIs with the Zilliqa JavaScript library. You can just directly, we have some APIs that you can use to fetch data from the chain. And yeah, all that is documented. We have documentation for it as well. And apart from this, we also have Scilla documentation. So if you are interested to learn about Scilla, I'll share all these links obviously down below. We have our block explorer. So as a developer, we have the whole ecosystem built out. If you want to check out transactions on using a UI interface, you can use our block explorer. It has Zilliqa, mainnet, testnet, and so on. Yeah, that's about it for the dev tools. Apart from this, just a brief mention of some DApps that are built on Zilliqa. So Unstoppable Domains is one DApp that is built that is quite popular actually. It allows you to basically by blockchain domain names. So it supports .zil and .crypto domain names. And we have, let's see if I have, yeah. So this is the website. You can check it out as well. Yeah, and we have Zilliqa Planet. So Zilliqa Planet is again a multiple games. It has a NFT marketplace. Amrit also had mentioned Mintable and Switch.io. These two are also dApps that are upcoming, and of course the whole OOPSLA ecosystem is also getting built. But these are sort of more developer sort of apps. I would say like developers like to make games and some passion projects and stuff. And yeah, Zilliqa Planet is actually on available on mobile. Yeah, I think it has around 20,000 users. So why to build on Zilliqa? There are 4 aspects to it. I would say the 2 main one would be scalability and the security. The scalability of the Zilliqa platform and the security of the Scilla programming language. And obviously there's low fees. So as a developer, this fees you are if say you are subsidizing for users fees, or if your users are paying the fees of the dApp themselves, this is a very major consideration. Like if you look at Ethereum right now, the fees are really high, and I have had so many developers asking me to move to Zilliqa because of the amount of fees that they're paying, and in some cases developers are themselves paying fees for the user. So yeah, that's low fees, scalability, security, and obviously the dev tooling. Dev tooling encompasses basically the IDE, Zilliqa JS library, the block explorer, and everything that makes it easy for you to build out a dApp, full stack solution using Zilliqa. And as Amrit had mentioned, we have Zilhive, which is basically a grants program that we run in, and it's basically 3 sub parts to it. We have an education program, we have a grants program in which we give out grants for people who are either maybe working on some interesting application on Zilliqa, building some toolkits, or in general, working to advance the blockchain industry. And we also have an accelerator in partnership with Tribe in Singapore, in which they incubate certain projects and take them through the whole phase of building a prototype, talking to customers, raising funds, and stuff like that. And Tribe is it's backed by the Singapore government. And we also have Zillacracy. So Zillacracy is something that you can check out. So Zillacracy is our initial initiative. Like say if you just want to get started, you want to help out writing a blog, you want to help out in building some dApps, helping out in some community initiatives, or doing some small projects basically. So we have Zillacracy, which is run independently by the Zilliqa community. Some of the Zilliqa team members are also part of it. Like I'm also part of it. Amrit is also part of it. But it's run by the Zilliqa community. Desmond, who's part of this call as well. He is the product owner of Zillacracy. And if you are interested, you can reach out to us. The website for Zillacracy is zillacracy.com. It's all community run. So if you're interested to look at some community projects, you can have a look, and we'll be happy to take it forward. Yeah, so that's about it. If you have any questions, we are available on Twitter, Telegram, all the social media channels. We have a Discord group. Also, we are recently launched our Stack Exchange proposal. So Zilliqa will have our own Stack Exchange, zilliqa.stackexchange.com in a couple of months as our proposal gets approved. If just feel free to reach out to us. We are mostly active 24/7 because we are spread out throughout the globe. So someone will get back to you instantly. So that's it. And maybe we can now take some questions from the audience.
Perfect. So thanks a lot for this deep dive into Zilliqa and Scilla. There are some useful links in the chat as well for participants. And please, Arnav and Amrit, check out the questions that
Yes,
are.
I'm starting with the first question, which I think was on Ethereum comparison with Ethereum 2.0. Yes, it's from Fox Riemann. Question: Ethereum 2.0 will also have sharding. What's your advantage? Okay, so to start with, Ethereum 2.0 is at least in the way it looks like. Ethereum 2.0 will build in phases. So the one that they're launching probably next month or in next 2 months is the phase 0 of Ethereum 2.0. Phase 0 will not allow every single feature that a full sharding environment will have. For example, cross-shard communication, which is very essential for a sharded network to have. So there will be a lot of features that will be progressively added in Ethereum 2.0, and until phase 4, if I'm not wrong, sharding will not be fully functional. So that's just to inform you of the way Ethereum 2.0 is going ahead. What we have as an advantage is, one, that we have something that's already live and running. So people who want to build applications and who require high scalability or high volume can directly build right now on top of Zilliqa. The second advantage is around Scilla, which is the smart contract language. So Solidity is still, even though Ethereum has invested quite an amount of resources on developing their smart contract language Viper, I don't think there's much attention going on that language in itself. So Solidity still remains a much preferred language on Ethereum chain, and which again has its own set of issues, which we feel Scilla can change. So I would say that these are kind of two advantages for Zilliqa. The second question is, why is Bitvavo not among the exchanges for staking? I'm not very familiar with this exchange in particular, but just to answer this question in a more broader sense, the total number of nodes that we can support in staking is, roughly speaking, is around 10. So we don't have too many choices on how many exchanges or how many other parties can support. What we try to strive to do is to be able to make sure that different entities will be able to get a part of this pie. It could be exchanges, it could be wallet providers, it could be explorers, it could be Zilliqa, for example. And the reason is that I believe staking the way we are doing staking is not the way, let's say, you are used to staking in a POS system like Tezos, Cardano, and others. The purpose of staking is, of course, to allow subspecific nodes, which are basically archival nodes, so they store transaction history, and allow them to provide this history to public. So if, let's say, if you are an app developer and if you like to know and get access to transaction data, then you could connect to these nodes. But these nodes do not participate in consensus. So they are very different from existing POS architecture. Now, given that, now if you look at who are these people who are running those nodes, most of them are exchanges or explorers. And what I also feel that this staking is also needed in a way to benefit some of these ecosystem players like wallet providers and explorers, because unfortunately these players, they do not have a consistent or sustainable source of revenue. So I think it's best to provide them a source of revenue through staking and help developers and the broader ecosystem to survive. Because in the end, these wallet providers and explorers need a way to sustain themselves. And this could be one mechanism. So unfortunately, we won't be able to support every exchange. So it would be a good mix of exchanges, wallet providers, and explorers, for example, and community initiatives like Zilliqa who will be able to provide a staking node. The follow-up question is, any info on technical architecture of Zilliqa blockchain? Some people shared the blog post that at a very high level defines and explains the high level architecture of Zilliqa. Just to summarize, the way Zilliqa works is the following. The network architecture consists of what's called shards. So on the mainnet right now, you have in total 3 shards, each containing 600 nodes, and one special shard that we call the DS committee, so Directory Service Committee. And each shard basically processes transactions. So every time transactions come into the network, they get divided into shards, and then each shard processes those transactions in parallel. The special role that DS plays is informing those shards. So imagine, for example, a network gets, a node comes in, and it needs to be assigned to one of those shards. The DS committee basically decides on where that node will go. In terms of processing the transaction, the network uses, as Arnav explained, this classical PBFT, a practical Byzantine fault tolerance protocol, to run consensus on whether a transaction is valid or not. And in order to form this entire network, we rely on proof of work as a civil resistance. So basically, every 2 hours, a node comes in and says, I want to be part of this network. And then they do a proof of work. And this proof of work basically gives them an entry ticket to the network. And based on the randomness that comes from proof of work, they get assigned to one of the, let's say, 3 shards. Sorry. And once you have these shards formed, then after that, you process transactions and validate transactions using PBFT, which is the classical PBFT, the consensus mechanism. I'm just scrolling down to see if there are no questions. I think that's yeah, someone mentioned that thank you for sponsoring events of tech, and you missed the hackathon in London. It's not a big issue. We always try to host hackathons. Unfortunately, due to this COVID situation, we can't do physical workshops, but we plan to do similar hackathons and workshops in the coming future as well. Yeah, I think is Zilliqa. Question on modularity. Are there ways to separate library code from contract code? Yes, the answer is yes, you can actually deploy an entire piece of code that's purely library. And that library, and that's exactly a distinction between Solidity and Scilla. In Solidity, there's no clear distinction between a piece of code or an actual contract, you may call it, that does not handle state, and a contract that actually handles state. So for us, you can technically deploy a code that has no state. So it's purely library contract. So imagine, for example, you want to write a code that does factorial computation or computes Fibonacci. So it's purely mathematical. And let's say you want to reuse it in multiple contracts. What you can do is you can write this Fibonacci function in your file, and you deploy it as a library contract. So it won't have any state whatsoever. And if, let's say, if you deploy at a later point of time, if you deploy a contract that wants to use that Fibonacci function that you develop in the other contract, you can actually import that and use it. Is there a desktop IDE? Unfortunately, we don't have a desktop IDE, but the plan is that we would like to convert this web IDE that Arnav presented into a desktop app, basically. So you can install it and they can use it. Sorry. Then you can use it as a desktop app. However, if you're familiar with, let's say, your favorite IDE, such as Emacs or Vim or even Visual Studio, sorry, even Visual Studio, you can use some of the plugins that have been developed for those IDEs to develop contracts. So for example, in Visual, for VS Code, there's a plugin that allows you to detect, sorry, that has syntax highlighting, and it also connects to Scilla checker automatically. So it has some linting support as well. So you could use your VS Code as an IDE framework as well. Unfortunately, it doesn't allow you to deploy contracts. So in order to deploy, you would probably have to use either the SDKs or have to come back to the web IDE to deploy the contract on the test node or the mainnet. But you can actually write your code and check for compilation or type checking errors. Is there a way to run Scilla in a terminal? Yes, there's a way to run Scilla in terminal. So you can basically go to Scilla GitHub repo, build a repo, and you will have 2 binaries. One will be Scilla checker, which is actually the type checker. So it will check whether your contract is syntactically correct and it has no type bugs. And then there's something called Scilla runner, which is basically the binary interpreter binary that executes your contract. So yes, it's possible to do that in a terminal as well. I think there's one last question. Is Zilliqa fun, interesting entertainment apps? I'm working on NFT collectible. The answer is yes. We are actually Mintable, which is a marketplace for NFTs, is something that has been funded by Zilliqa. So yes, in principle, yes. But it also depends on the quality of app that you're trying to build. Sorry. So for ID, SSIs and DIDs, yes, we are looking for, we are actually in touch with some parties in Singapore, developing DID-like solutions. Unfortunately, it has not been finalized. So, but yes, there's something, if you are interested in building a DID layer, we are definitely open to it. The scalability of Zilliqa of linear nature, have other scalability ideas of thought of. So we have not looked into anything that can go beyond linear scaling, to be honest, so far. We feel that there is definitely a research element to it to see if we can expand this, but we have not done proper research on other ways to increase the scalability of the platform. Yeah, that's all. I think we have answers all questions. Well, thank you very much for all the questions. It was lovely being here.
Thank you so much, Amrit, and thanks everyone for joining. Please stay tuned for upcoming webinars as well, and we hope to see you soon. Make sure to follow Zilliqa as well.
And a small announcement: we before everyone heads out, we have a form that you can fill, and you'll get updated for our Learn Scilla series, and we are even giving out some Scilla t-shirts, some Zilliqa merch. So I think Rudolph will share that within the group, or Milan, if you can share it.
Yes, we'll do
within the chat. Yeah, or on this
so
chat.
please share it in the chat as well, and we'll send an email afterwards to you.
Yeah.
Cool. Thanks,
Yes.
everyone, and speak soon.
Thank you very much, Rudolph, for inviting us over.
Yeah. Thanks, Rudolph.
Entirely our pleasure. Thank you.
Bye. Bye, everyone.
Thank you.